We'll record this. Spherical cell, 90% water. So, what we know is that it has a diameter of 1.0 micrometers, or 1.0 times 10 to the negative 6th meters, right? This is all rehash of yesterday. We know that the volume of a sphere is 4/3 pi r cubed. Yeah? So, to find this, I think the fastest, easiest way to do it, just for my money, is, yes, you need a calculator. You never sit down in physics without a calculator. Silly rabbits. Gesundheit. Okay, why'd I do it that way? Because it's easy and I don't have to do math until one thing. I just throw it all together in one big thing. Why is this divided by 2? Diameter radius. Yeah, diameter radius. So that's pretty darn easy. Now, if I was just okay, well let's leave it right there. So remember, these are supposed to be kind of like fast estimations. So I'm going to do the actual calculation through, and we'll look at the real numbers, and then we'll do sort of a Fermi answer for it. Okay, so if I plug that exact thing into my calculator, I get 4.188, who cares, all bunch of numbers, times 10 to the negative 18th. Or, in a Fermi answer, I get 4 times 10 to the negative 18th. Close enough. So this is still the volume of our sphere. Now, I'll pause. To fill this box that's sitting on the moon with micrometeors, and we have the diameter of the micrometeors. It is 1 times 10 to the negative 6th meters. And we know that one of them hits every second. 1 micrometeor strikes each square meter of the moon every second. So we have 1 falls each second. Okay. I don't know how many of them will fit in a box, first of all. Because if we think about our answer is going to be how long would it take to fill the box with micrometeorites. So it's going to be, our final answer is going to be in seconds per, we'll call it, full box. And I find, especially with the more sort of amorphous ones, this is what we talked about last night. If I draw my picture, draw the situation, and then I look at, okay, what is my final answer actually going to be in? Well, it's going to be in how long does it take to make a full box? Seconds per full box. What that does is that starts to guide me when I set up a factor label. So if I start off and I've got, seconds on the bottom somewhere, I look back at this and go, oh, I'm screwing something up. So I find that laying out what units I'll end up in initially is helpful. So let's get rid of the circle. Let's shrink this. So first we need to know how many of them it's going to take to fill the box, right? So the things that we're going to need to know, number in a full box, we'll call it FB, number in a full box, and number per second, which we have. And then, okay, since we want seconds per full box, will those 3 things get us an answer? Do we have the 3 things that we need to do a factor label? Yeah, we do. So let's shrink this.
Do we do the thing where we treat the meters as cubes?
Oh yeah, absolutely. Yeah, to find how many of them fit in a box. I mean, it's a Fermi thing, so the easiest thing to do is approximate their volume as cubes, and then just go from there. Because they're not gonna fill space. Spheres don't fill square spaces. Okay, so let's start with the volume of the meteorites. volume of the box, so we get a number for that. So if we treat the diameter as an edge and treat them as cubes, then we get a volume for the meteorites of 1 times 10 to the negative 18th. Okay, so we've got the volume of the micrometeorites, 1 times 10 to the negative 18th cubic meters. The volume of the box, well, the box is 1 meter by 1 meter by 1 meter, right? So that's 1 meter cubed. So how many, to figure out how many micrometeorites would fit into the box, we take the volume of the box divided by the volume of the little tiny cubes, right? All right. Okay, so volume of box divided by volume of micrometeorites equals the number that can fit in a full box. We could actually set that up as our first cell in a factor label if we wanted to make a really long factor label, which I love. So we have 1 cubic meter is 1 box. Oh, I can't do this in this space. Okay, we'll just go ahead and do a new page to set this up. So we'll start off with the 1 cubic meter box, the 1 times 10 to the negative 18th cubic meter micrometeorite, and that's the number of those in a full box. So then, if we know that, we can do the number of micrometeorites per second, and that's 1 per second. What was the other factor we said we needed? We said we needed we wanted to end up in seconds per full box. Well, let's look at this. Okay, so I've done something wrong here. This would end up being how many boxes we could fill per second. That's not what we want. Okay, so and this is, it's okay to go down a blind alley and catch yourself. And that's also why I tend to lay things out and know what units I need to end up in. So we need to end up in full boxes, or no, seconds per full box. Seconds per full box. Okay, so let's start over. It's still valid to say that dividing the volume of the box by the volume of the micrometeorites gets you the number in a full box, right? Yeah. So that ends up at 1 times 10 to the 18th micrometeorites per box. That's what we want. That's what we want right there.
So that's the answer, right? Since they equal.
Pardon? Okay, so if we take that, so 1 times 10 to the 18th micrometeorites in 1 full box, and 1 micrometeorite falls every 1 second, it's going to take 1 times 10 to the 18th seconds to fill a box. Now I think they ask you, oh, it just says how long. Now I will say, that's not really a great answer for how long, because what does it mean? Like, is that a couple of weeks? Is that a couple of years? Is that a couple of centuries? So to make it an answer that you actually understand, it's a good idea to take that and convert to something more understandable. Per micrometeorite. So actually what we're saying is 1 micrometeorite falls every 1 second. And because that's just a relationship, we can put either one on top or bottom depending on what we're relating it to. Good question. Meteorite. Yeah, and it's hard to read. Sorry. Okay, so if we take 1 times 10 to the 18th seconds, 3.6 times 10 to the third seconds in an hour. And 2.4 times 10 to the first hours in a day. And 3.7 times 10 to the second days in a year. We get 1 times 10 to the 18 divided by 3.6 times 2.4 times 3.7 all times 10 to the, that's third, not negative third, 10 to the 3 plus 1, 4 plus 2 times 10 to the sixth. So I threw a little bit of quick, sort of rough, 30,000 years. It's quite a while. It would take a long time.
If you had the second, would you have marked that wrong?
I wouldn't mark it wrong. I might take off a point because it's, out of 10, because it's, I probably won't on this test, honestly, just because it's...
It's like, yeah, I didn't have to.
I mean, you should, I probably wouldn't, I'd probably write you a note, but you do want your answers to be in something that you can wrap your brain around, so, okay.